M7, you've got a big play. You made some big announcements today with the Internet of Things. Tell me what you announced. Let's drill into that just a little bit.
So what we really announced today was a couple of major announcements, and we did one last week as well. So we announced the mbed platform, which is really driven by how a platform that software guys can really port and enable new uses for the Internet of Things. And then we announced the operating system that goes with that as well, so mbed OS. And early last week we announced Cortex-M7, which is a core specifically designed with DSPs, so you can do much more fine-grained embedded applications with that relevant DSP sitting next to it as well, and with new low-power usages as well. So that whole embedded environment needs to target not just low power, but applications and application support. And what we're doing here is taking that deeply embedded application, which has always been quite technical to go do, and raising it up so you can have art students programming something, and students in high school being able to create new products, and the maker fairs being able to go and generate new products without having that deep embedded knowledge of some of those DSPs and some of that underlying core technology. What we're doing is creating this environment that makes it easy for people to go create the databases, make it easy to go program, rather than having that technical knowledge to go do it. That's what mbed's all about.
So one of the questions I have for you is Big Little. How does that pertain to the new M7 announcement or future announcements?
Big Little is part of our Cortex-A architecture, so applications. The Cortex-M7 is part of our microcontrollers, so that's really a standalone. But the Big Little architecture that we announced a few years ago for 32-bit and now moving into the 64-bit area is becoming widely adopted amongst a lot of our partners. And we see that growing the dynamic range and the power performance of chips. We're seeing that being used in multiple different varieties in multiple different ways. We've seen it in servers and embed from server applications all the way through to phones and tablets. We see that client architecture of Big Little being expanded over time, and you'll get much more used to having different cores and the right cores running the right job at the right time.
Does that imply heterogeneous cores and maybe a mix across the M and the A and maybe even the C series of products?
If you were to look at the way the SoC companies design cores, you're getting heterogeneous cores in an SoC anyway. Every A-class core has got a timer in there and a controller in there, which tends to be Cortex-M. You're getting that anyway. So how they work together on a bus, whether it's synchronous, asynchronous, we've been doing that for a long time. People talk about these new architectures. Our partners have been doing this for a long, long time. Go back and have a look at some of the original Nokia phones. They were heterogeneous then as well.
Data. To what extent is ARM helping to protect my data or giving me trust and assurance?
We do a number of things. We have, at the very base layer, some cores that are really designed to protect data, so things that go into smart cards and SIMs and credit cards that are tamper-proof, and we license those out. Then in our standard cores, in our A-class cores, we put something called Trust Zone in there, which allows virtualization and secure protection in there. You can do secure keys in there. We're also working on a secure environment in the M class as well. You then move up to a server environment where we work with the virtualization companies, we work with the standardization companies, really to drive some of that security standards across a solution and across a platform, not just across a chip. Because security comes from not just one point, but comes from that whole system being secure. And that's what people are really looking for. And without that security of the data, the authentication and trust of that data will fall down. And consumers, whether they're being in a home or in a big bank, will not trust the data as much as they should do.
Can you talk about any new features in the M7 or on the follow-on roadmap that are going to enhance security? Anything you can say today?
We look at security in a number of different ways. We put DSPs inside of the Cortex-M7, which some of those will be used for security. We have clearly worked with encryption engine companies that will sit next to the M7 as well, so sitting next to that on a bus, and we have future plans to go and enhance security going forward.
Outstanding. I'm just so thrilled to be here. I've learned so much today. The announcements are truly, in the case of one ARM partner this morning, truly seminal announcements, and I believe that as well. Sensor to server, amazing. I'm here with Ian, ARM TechCon 2014, Chris Ciufo, Extension Media. Ian, thank you very much. I really appreciate it.
Thank you very much indeed.